Alrighty, so we got this whole thing laid out. Running right now, discharging. I'm pulling power from the AC of the house instead of the generator, obviously. Hooked up to AC 120 for now. That changes over to DC 160, which that guy outputs 160 volts to DC. Stable at around 2,700 watts, so we're good there. Balancing these cells as they're discharging. And once we hit a certain threshold here of 44.2 volts, which is my cutoff, the controller will take over and turn on these power supplies. They're off right now. We've got remote switching control of the power supplies. Toggle this relay on to open the bus between the power supply and the battery setup. Battery. And yeah, then the servo potentiometer here controls the slave power supply. These are set up in series for 12S. And as soon as we get to the threshold voltage here at 44.2, we're still a ways out. Still a little ways out from the battery voltage. Once it gets there, this whole thing will start to turn on. And it'll hold about 25 amps using that current sensor and servo trim. These are load cells I'm using to pull the power battery out after it charges up, so I can cycle the charger to test the system. Since we're charging here at essentially 12S, 35C 12S. So I want to get these packs charged as quickly as possible. So yeah, you don't really want to stick your hands in here when this thing's running. Yeah, 12S charging setup at 5C charge rates. So quite a lot of power here. So this pack we're looking at around 2,000 watts, 1,800 watts to get to the 5C limit of charge rate. Just gonna toggle on in a second here. These will come on to indicate that the power supplies have turned on. So the chargers are there just as a indicator. There it is, it came on. A little PID issue there. A little oscillation on the PID loop that's controlling my trim. Gotta tune that PID a little bit better. There's a current draw right now from the current sensor. About 26 amps. Pretty neat. A lot of power flowing through this thing right now, so I'm a little nervous, but we're talking 25 amps at 50 volts, or 49 volts. So that's your current, 25 amps, and that's the bus voltage of the power supply. That blue second channel there is hooked up to my McSig current sensor, and then the yellow is the differential probe hooked up to the output of the power supply, or the power supply is in series rather. So right now we're charging and pulling a load. The load gets sent to that system over this wire. So this wire is running that motor in the background over there. You can go look. Turn that down a little bit. Let the battery charge a little quicker. That'll compensate over here. Give the servo a little bit less current oscillation to work with. So the system triggered on about 3 minutes ago, 9:44, and that's our values right now as of 9:44. Batteries come up quite a bit. We're still charging at around 25 amps. The trim has come up quite a bit as well, so you can see here that the servo's extended quite a bit more as it's increasing the voltage of the slave power supply to allow more current to flow into the batteries. These batteries are reading 90% charged already, and it hasn't even been 5 minutes, so 90% on this one, so a little bit of an unbalance there, but it's charging while also having to deal with the load of that motor again, because that motor is still pulling from that bus, and it's still running. So it's charging and feeding a motor to simulate an aircraft flying. Pretty sweet. Next big event here is actually going to be the disabling of the trim. So the trim's still enabled, but it's maxed out, so the servo is fully extended. But in a second, the trims will open up wide open, so that the full current of the power supplies can be released onto the packs and onto the bus. So that should happen here shortly when this LED turns off. It will cut off power from the. Should happen here shortly. Hopefully there won't be any oscillations. So we should see quite a current spike when this occurs. 14 amps. We're just there. Yep, there's a current spike. So, but that's within safe limits, so that no oscillations occurred. And then the trim servo reset back to its neutral position there, fully unextended. And then there, the power supply toggles off. power supply so it can remotely shut off as the battery has reached a certain voltage and is within range. So that's it, and that's a full charge of a battery, 12S, setup, 7,000 amp hour, in about, I don't know, 7 minutes. So, and these are within safe margins. I mean, we're charging at, cut in is 44.2, and then I'm cutting off at 49, which is leaving them a little low, but that's just for safety reasons, because I'm so close to everything right now. So now the big challenge is to cut that guy in and disconnect from the AC 120 so I can source the power from diesel. Let's go.